Now, everybody knows big O notation, right? If you study computer science, you'll learn about this in your first year, if not your first semester. Please allow me to be pedantic for a second. First of all, and you see this a lot to the extent that I would say this is actually accepted notation, but I will silently judge you. Technically, big O is a set of functions. So if you write something like 42n squared equals O of n squared, well, that's a type error. You could use an element of operator, 42n squared, element of on squared, but I'll admit that feels very pedantic even to me. What I tend to do is I write the word is, like 42n squared is O of n squared. Maybe that's me being Dutch, but here we are. Secondly, don't leave constant factors in the big O, like O of 2n. This is one I only see students do, and like technically you're not wrong, but I would say there's basically zero tolerance for writing this in a paper, unless you're doing it to make a very particular point. As a student, I once forgot to simplify square root of 4, and like I wasn't wrong per se, but it sure is a silly way to write 2, and O of 2n is similarly ridiculous. Finally, big O technically needs to know which variable is going to infinity. Usually this is obvious from context, but I do find O of 1 particularly funny in this sense. Should it kind of maybe be O of lambda n goes to 1? Nobody's going to write that, of course, but I do want you to make sure that it is actually clear from context which variable or variables are going to infinity, especially if there are multiple variables or no visible variables at all, like the O of 1 thing. And I did call this episode Pedantry. You see, I cover my bases like that. At some point, a paper did actually confuse me for a second, because there was an n and a k, and it called a bunch of things O of 1, which initially I thought clearly also included the dependence on k, but for them it was a constant. So then, yes, well, okay, I guess O of k is O of 1 if k doesn't go to infinity.